For the thermal efficiency, little e, it's defined by the work done divided by the heat taken in from the high reservoir. So this is 2,000 joules over 10,000 joules, which is 0.20 or 20% efficiency. For the heat discarded, we know that the work done is going to be the sum of the heat from the high reservoir plus the heat from the low reservoir. So the heat from the cold reservoir is going to be the work minus the high reservoir heat. So this is 2,000 joules minus 10,000 joules, or negative 8,000 joules. The negative just shows that it's leaving the system or the engine. Part C, we want to find the power, and the power is going to equal the energy per cycle times how many cycles per second, which gives us 50,000 watts. And then to find it in horsepower, we take the 50,000 watts and multiply by 1 horsepower is 746 watts, which gives us about 67 horsepowers. For part D, how much gasoline is burned each cycle. The burning is a phase change from liquid to gas, so it's going to be the mass times the latent heat of combustion, which means that the mass is going to be the heat over the heat of combustion. That is 10,000 joules divided by 5.0 times 10 to the 4th joule per gram for gasoline, and that is 0.2 grams per cycle. And lastly, for part E, we're asked how much gasoline is burned per second. And we can do the mass of gasoline burned per second equals the mass per cycle multiplied by the number of cycles per second. So the mass equals 0.2 grams per cycle times 25 cycles per second, which gives us 5 grams per second. And then if we want to find per hour, that would be 5 grams per second times 3,600 seconds per hour, or 18,000 grams per hour, which is the same as 18 kilograms.